Good morning, students. I am Riya Sinha, your SST teacher. Today, we are going to start our fourth chapter of geography, that is air. We all know that our earth is surrounded by a huge blanket of air, which is called atmosphere. All living beings, whether it is plant, animal or human beings on this earth, depend on the atmosphere for their survival. It provides us the air we breathe and protects us from the harmful effects of the sun's rays. And without this blanket of protection, we would be baked alive by the heat of the sun during day or get frozen during night. So it is this mass of air, this blanket of air, that has made the temperature on the earth livable. So in this chapter, we are going to learn about composition of the atmosphere. So do you know that the air we take in while breathing is actually a mixture of many gases. Many different kinds of gases are there in the air which are present in our surrounding. Nitrogen and oxygen are two gases which make up the bulk of the atmosphere. Some other gases are also there, like carbon dioxide, helium, ozone, argon and hydrogen, but they all are in lesser quantities. Apart from these gases, tiny dust particles are also present in the air. See, a pie chart is given in which percentage of different constituents of air is shown. Nitrogen is 78%, oxygen 21%, carbon dioxide 0.03%, argon 0.93% and all other gases are 0.04%. So according to this pie chart, we all are able to understand that nitrogen is the most plentiful gas in the air. When we inhale, we take some amount of nitrogen into our lungs and exhale it. But plants need nitrogen for their survival. They cannot take nitrogen directly from the air. Bacteria that live in the soil and roots of some plants, they take nitrogen from the air and changes its form so that plants can use it. Second most plentiful gas in the atmosphere is oxygen. We all, animals and human beings, take oxygen from the air as we breathe. Green plants produce oxygen during photosynthesis, and in this way oxygen content in the air remains constant. If we cut trees, then this balance gets disturbed. Next is carbon dioxide. Carbon dioxide is another important gas. Green plants use carbon dioxide to make their food and release oxygen. Humans or animals release carbon dioxide. The amount of carbon dioxide released by the humans or animals seems to be equal the amount used by the plants, which make a perfect balance. If we cut trees or plants, then obviously they are not able to consume carbon dioxide, and in our surrounding its quantity, day by day, gradually its quantity will increase. However, the balance is upset by burning of fuels such as coal and oil. They add billions of tons of carbon dioxide into the atmosphere each year. And as a result, the increased volume of carbon dioxide is affecting the Earth's weather and climate. Day by day, our earth is becoming warmer. Now, why it is becoming warmer? Because of carbon dioxide. See, carbon dioxide released in the atmosphere creates a greenhouse effect by trapping the heat radiated from the earth. So it is also called greenhouse gas. And without it, the earth would have been too cold to live in. However, when its level in the atmosphere increases due to factory smoke or car fumes or fuels, the heat retained increases the temperature of the earth, and this is called global warming, through which the temperature is rising gradually day by day. This rise in temperature causes the snow in the coldest part of the world to melt. As a result, the sea level rises, causing floods in the coastal areas, and there may be drastic changes in the climate of a place, leading to extinction of some plants and animals in the long run. So, till now we have discussed about composition of the atmosphere, in which we came to know that nitrogen is the most plentiful gas in the air, oxygen is the second most plentiful gas, carbon dioxide is another important gas which is also known as greenhouse gas, and some other gases are also there like helium, ozone, argon, etc. So mainly till now we discussed about our atmosphere. We came to know that a huge blanket of air which surrounded our earth is called atmosphere. All the living beings on this earth depend on the atmosphere for their survival. It provides us the air we breathe. It protects us from the harmful effects of the sun. Next, we have discussed about composition of the atmosphere, in which we used to learn that nitrogen and oxygen are two gases which make up the bulk of the atmosphere, and carbon dioxide, helium, ozone, argon and hydrogen are found in lesser quantities. Okay, now we have discussed about greenhouse and global warming also. Carbon dioxide has special function that it released in the atmosphere and creates a greenhouse effect by trapping the heat radiated from the earth. So it is also known as greenhouse gas, and without it the earth would have been too cold, because it increases the temperature of the earth, it maintains the temperature of the earth, but if its quantity increases because of some human activities like factory smoke or car fumes like that, then the heat retained increases the temperature of the earth, and this is called global warming. This global warming have hazardous impact on our earth. Its rise in temperature causes the snow in coldest parts of the world to melt, and as a result the sea level rises, causing floods in the coastal areas, and there may be drastic change in the climatic condition of a place also, which leads to the extinction of some plants and animals in a long run. We are going to start our new topic, that is structure of the atmosphere. So our atmosphere is divided into 5 layers, starting from the earth's surface. See figure 4.2, layers of the atmosphere. Starting from the Earth's surface, first layer is given here is troposphere, in which one mountain kind of structure is given, that is Mount Everest is written. So this is the layer in which we all live. Then a thin line of separation is made between troposphere and the second layer, and its name is tropopause. The line of separation between troposphere and the second layer of the atmosphere is known as tropopause. Then C, second layer of the atmosphere is stratosphere, in which an aeroplane and ozone is written. In the second layer of the atmosphere, which is known as stratosphere, ozone layer lies in this layer only, and it is very convenient to fly an aeroplane because their weather phenomenon is not associated here, no cloud formation is there, or it makes condition most ideal for these kind of activities. Again see, there is a thin layer of separation between stratosphere and third layer of our atmosphere, known as stratopause. Third layer is mesosphere. Some star-like particles are there, actually that one is meteoroids. When some meteoroids enter into our atmosphere, then from this layer they used to start burning. Then a thin layer of separation is between mesosphere and fourth layer, known as mesopause. Then thermosphere is there, and at the top uppermost layer is exosphere. Now we will discuss it one by one individually. C, troposphere. This layer is the most important layer of the atmosphere. Its average height is 13 km. Average height of the troposphere is 13 km. It is the most important layer of the atmosphere, and it is the bottommost layer. The air we breathe exists here. Almost all the weather phenomena like rainfall, fog, hailstorm, etc. occur in this layer only. So what we have learned, that it is the most important layer of the atmosphere and its average height is 13 km. The air we breathe exists here. Next layer is stratosphere. Above the troposphere lies the stratosphere, as we have seen in the figure also. It extends up to a height of 50 km. And this layer is almost free from clouds and associated weather phenomenon, making condition most ideal for flying aeroplanes. One important feature of the stratosphere is that it contains a layer of ozone gas. We have just learned how it protects us from the harmful effects of the sun rays. So, average height of troposphere is 13 km, average height of stratosphere is 50 km. Third layer is mesosphere. So this is the third layer of the atmosphere. It lies above the stratosphere and extends up to the height of 80 km, 80 km. Okay. Meteorites burn up in this layer on entering from the space. First we have learnt about troposphere, whose average height is 13 km, then stratosphere, whose average height is 50 km, then mesosphere, which extends up to the height of 80 km, and now fourth one In thermosphere, temperature rises very rapidly with increasing height. Ionosphere is also a part of this layer. It extends between 80 to 400 kilometers. This layer, this thermosphere, helps in radio transmission. In fact, radio waves transmitted from the earth are reflected back to the earth by this layer. So, troposphere 13 km, stratosphere 50 km, mesosphere 80 km, thermosphere 80 to 400 km. And last but not the least, exosphere. The uppermost layer of the atmosphere is known as exosphere. This layer has very thin air, so light gases like helium and hydrogen float into the space from here. So, in this topic, structure of the atmosphere, we came to know that our atmosphere is divided into 5 layers, that is troposphere, stratosphere, mesosphere, thermosphere and exosphere. Troposphere is the most important layer of the atmosphere and the bottommost layer. Its average height is 13 km. The air we breathe or on which we depend for our survival is present here, and almost all the weather phenomena occur in this layer. Then stratosphere. Stratosphere, average height of extension height of stratosphere is 50 km. It contains a layer of ozone gas. None of the weather phenomena is associated in this layer, so it makes ideal condition for flying aeroplane. Third is mesosphere, which lies above the stratosphere and extends up to the height of 80 km. Meteoroids burn up in this layer on entering from the space. Then comes thermosphere, in which temperature rises very rapidly with increasing height. Ionosphere is part of this layer and its height extends up to 80 to 400 km. This layer helps in radio transmission. And then comes the uppermost layer of the atmosphere, which is known as exosphere, which is very thin and light gases float into the space from here. We will continue the topic air pressure. It is defined as the pressure exerted by the weight of air on the Earth's surface. So as we go up the layers of the atmosphere, the pressure falls rapidly. Atmospheric pressure is defined as the pressure exerted by the weight of the air on the Earth's surface. The atmospheric pressure can be measured by an instrument called barometer. The normal atmospheric pressure at sea level is about 76 centimeters of the mercury column in the barometer. Now, horizontal distribution of pressure. Whenever there is increase in the temperature of the air, it gets heated and expands in volume, and due to less weight, the heated air rises up, causing low pressure. But at high altitude, the same air gets cooled and becomes heavier, and thus it descends down, causing high pressure. This is vertical distribution of pressure. Atmospheric pressure decreases while going up, and as we go up, the atmosphere becomes thinner and thinner, and its pressure also goes on decreasing. This is the reason why high pressure is found at the sea level due to dense atmosphere. The lower areas or plains have high pressure, but on the mountains there is low pressure.
Now see the world pressure system. The main pressure belts of the world are the following. First is equatorial low pressure belt. Second is subtropical high pressure belt, subtropical low pressure belt, and polar high pressure belt. C. Equatorial area is a region of high temperature. Due to intense heating, the atmosphere heats up, expands, and becomes heated. Hence, the air starts rising up in vertical ascent, causing low pressure. The horizontal movement of wind in this belt is very feeble. It is therefore a calm belt. It is also known as doldrums, which you will read in higher classes. It is a zone of wind convergence. This belt extends between 30° and 35° latitudes in both the hemispheres. Here the winds are comparatively dry and calm. This is a zone of descending winds and wind divergence. This region or belt is often referred to as horse latitude. Now see subpolar low pressure belt. This belt extends between 60° and 65° latitudes in both the hemispheres. This is a zone of wind convergence. The rotatory movement of the earth causes low density of atmosphere over this belt. Hence the atmosphere over this belt is thin, and thin atmosphere can exert only low pressure. Now polar high pressure belt. Around the North Pole and the South Pole, the temperature remains low and thus a permanent high pressure develops over the poles. Okay, next topic is wind. The movement of air from high pressure to low pressure area is known as wind. So let's discuss about it. See, due to horizontal difference in air pressure, air flows from the area of high pressure to the area of low pressure. This movement of air is known as wind. A wind is named after the direction from which it blows. Example, the wind blowing from the west is called westerly, blowing from east known as easterly. So there are different types of winds: permanent winds, periodic winds, or local winds. Permanent winds. The wind which blow throughout the year in a particular direction and over a particular region is known as permanent wind. They are also known as prevailing wind or planetary winds. Okay, next type is periodic wind or seasonal wind. These are the winds which blow over a particular period of the year in a particular definite direction over a particular area. These winds develop due to unequal heating and cooling of the surface of the earth. The periodic winds or the seasonal winds are also called monsoon. Monsoon winds are seasonal winds which blow from sea towards landmass in one season, and then from land towards sea in the other season of the year. During summer season, the land mass heats up rapidly and an intense low pressure area develops over Central Asia, which attracts the winds from high pressure. As a result, the southeast trade wind across the equator blow over the Southeast Asia and brings heavy rainfall to several parts of Asia. These are known as summer monsoon or southwest monsoons. During winter season, the land mass becomes cooler and the pressure over Central Asia becomes high. From this high pressure area, the winds blow towards equatorial low pressure area in the northeast direction. These are known as winter monsoons or northeast monsoons. Next is local winds. Local winds blow over a limited area and have local significance only. The amount of water vapor or the moisture present in a given volume of air is termed as humidity. It helps in cooling and heating of the atmosphere, or we can say it moisture also sometimes. The actual amount of water vapor in a given volume of air is known as total humidity or absolute humidity. The ratio between the actual amount of water vapor present in a given volume of air and the water vapor which the same volume of air can contain till its saturation level is called relative humidity. Now see condensation. Due to decrease in temperature, the water vapor starts converting into water droplets, and this process is called condensation. It has various forms also, like dew. On cool nights during winter, when the earth radiates heat and gets cooler, then the air which comes in contact with the cool ground also becomes cooler and water vapor starts condensing over the grass, trees, leaves, etc., which could be seen in the early morning, and this is called dew. Next is frost. When the temperature falls down to 0 degrees Celsius, the water drop forms ice crystals which are known as frost. Next is fog or mist. Fog is formed by the condensation that takes place on the dust particles floating near the earth's surface. It can be seen during the peak winter season. Clouds. Clouds are a mass of minute droplets of water formed by the condensation of water vapors in the upper atmosphere. See precipitation. It is a process under which the condensed water vapor falls on the ground in various forms such as rain, snow, sleet, and hail. Rainfall is the falling down of moisture from the atmosphere in the form of liquid water drops. It is of three types: convectional rainfall, relief rainfall, and cyclonic rainfall. See convectional rainfall. When the air comes in contact with the hot surface of the earth, it gets heated, becomes lighter, and starts rising up. Thus, convectional currents are formed. On reaching the upper layer of the atmosphere, the air starts cooling. Then condensation takes place and clouds are formed, and if a critical temperature is reached, then the rain occurs, and this is called convectional rainfall. Next is relief rainfall. When the relief features such as mountains come in the way of a moist wind, then the wind is forced to back and change its direction, and the rising wind starts cooling, and then condensation takes place. Next is cyclonic rainfall. Cyclones are the centers of low pressure. The air converges from all directions towards the low pressure, and it is forced to move in another direction. The rising air gets cooled, condensed, and clouds are formed, which ultimately bring rainfall. Now we have completed the explanation of this chapter. Hope you all understood the covered topics well. Thank you and have a nice day.